Have you ever wondered how a tiny atom can hold the power to light entire cities or launch rockets into space? That incredible energy lies deep within the atom, inside nucleus, and when that power is released, we call it nuclear energy. In this video, we will explore what nuclear energy is, how it produced, where it used, and what makes it both a promise and a concern for the modern world. Welcome to Fluky Facts, where we simplify complex ideas and make learning interesting for everyone. Nuclear energy is the energy released from the core of an atom, known as the nucleus. It produced when the powerful bonds that hold the nucleus together are broken or fused. This energy is clean, highly efficient, and has a tremendous energy density, meaning even a small amount of nuclear fuel can generate huge amount of power. Unlike fossil fuels, nuclear energy doesn't rely on burning. It depends on physics at the atomic level. Everything around us, the air we breathe, the chair you sit on, even your own body, is made of atoms. At the center of every atom lies a nucleus, which contains protons and neutrons bound tightly together. The energy that holds these particles together is enormous. When those bonds are broken or fused, a small amount of mass converts into a massive amount of energy. Just as Einstein's famous equation E equal to mc square predict. That's the secret of nuclear energy. A tiny loss of mass creating an enormous burst of power. There are two main processes to release nuclear energy. One, nuclear fission, and two, nuclear fusion. In nuclear fission, scientists split the heavy atoms like uranium 235. This technology used in today's nuclear plant. However, in nuclear fusion, combining of light atoms like hydrogen isotopes produce energy. This is the process that powers the sun and the stars and represents the future of clean energy. In a nuclear fission reaction, a uranium nucleus is bombarded by a neutron. It becomes unstable and split into smaller nuclei, releasing heat and additional neutrons. Those new neutrons go on to strike other uranium atoms, creating a chain reaction. If the chain is controlled carefully, the released energy can be converted into electricity. That's how modern nuclear reactors operate. Not explosion, but controlled fission reaction, producing steady, reliable power. Nuclear fusion is the opposite process. Two light atoms merge to form a heavier one. For example, hydrogen atoms combine to form helium, releasing huge energy. This is how the sun and stars generate heat and light. Fusion produces no carbon emission, almost no long-lived radioactive waste, and yields far more energy than fission. Although scientists haven't yet created a stable, large-scale fusion reactor, projects like ITER in France leading the research. And to create limited safe energy source, the power of the star right here on Earth. A nuclear power plant works very much like a thermal power plant, except the fuel is uranium, not coal. It has several key components: fuel, uranium or plutonium rods, control rods absorb extra neutrons to keep reaction stable, coolant transfers heat from the reactor core to produce steam, turbine convert that steam energy into electricity. In essence, nuclear energy heat water, create steam, spin turbines, and power entire cities. The difference lies in how cleanly and efficiently it does that. Here's an amazing fact. A single uranium fuel pellet the size of your fingertip can produce as much energy as 1 ton of coal or 120 gallons of oil. That's the incredible efficiency of nuclear energy. Beyond electricity, nuclear energy touches many parts of our lives. Like in medicines, radiation is used to diagnose disease and treat cancer. In agriculture, food irradiation helps preserve crops and prevent spoilage. In industry, it is used for material testing and sterilization. And in space exploration, nuclear batteries power spacecraft that travel beyond the reach of solar energy. It's not just power generation, it's technology shaping modern civilization. Nuclear energy offers some clear advantages. High energy density. A small amount of fuel generates massive power. Low carbon emission. It doesn't release greenhouse gases like coal or oil. reliable supply provides steady 24 by 7 electricity. Energy independence helps countries reduce reliance on fossil fuels. This makes it one of the few energy sources capable of supporting a large population while keeping emission low. But every powerful tool comes with its challenges. Radioactive waste disposal remains one of the biggest problems. It must be stored safely for thousands of years. Accident risk events like Chernobyl 1986 and Fukushima 2011 reminds us how devastating a failure can be. High initial setup costs make nuclear plant expensive to build and public fear. Many people associate nuclear energy with danger rather than progress. Managing these issues is the key to building public trust and safer nuclear futures. India entered the nuclear era in 1956 with the Apsara reactor, our first research reactor. Later, the Nuclear Power Corporation of India Limited (NPCIL) was established to manage civilian nuclear power. India follows a three-stage nuclear use of uranium in pressurized heavy water reactors, recycling plutonium from spent fuel in fast breeder reactors, utilizing thorium, a resource where India has global advantages. The program aims to achieve energy self-sufficiency using India's abundant thorium reserves for long-term sustainability. India's major operational nuclear power plants include Tarapur in Maharashtra, Kundankulam in Tamil Nadu, Kakrapar in Gujarat, and Aravatbhatta in Rajasthan. Together, they contribute significantly to India's total electricity output. Ongoing projects aim to increase nuclear shares in the national energy mix, part of our journey towards a cleaner power. Here's the environmental perspective. Nuclear power is 90% carbon free in electricity generation, meaning it helps reduce greenhouse gases. However, the system requires 100% safe waste storage because radioactive material must be isolated for centuries. The balance between clean power and safety responsibility defines the future of nuclear energy. India promotes nuclear power as part of its clean energy mix alongside solar and wind, a practical approach to sustainable development. The future of nuclear energy lies in innovation and cooperation. Fusion technology, the next frontier, safer, cleaner, and limitless. Small modular reactors, compact, cost effective, and flexible. Thorium reactors, India's unique contribution to global research. Global cooperation, partnerships through IAEA and ITER strengthen safety and progress. Nuclear power is not just an option anymore. It's becoming a necessity for the world's growing energy demand. So, can nuclear energy truly become the clean fuel of the future? Can humanity use the power of atom responsibly for light, not for destruction? Share your thoughts in the comment below. We had love to know what you think. If you found this video helpful, please like, share, and subscribe to Fluky Facts, where we simplify complex ideas and make learning easier for everyone. Check out our earlier videos on inflation, Human Development Index, and India-USA relations. The links are available in the description below, also in the I button. Keep learning, keep questioning, only on Fluky Facts. Think unlimited.